All right, hello. If you're watching this video, it's because you need help with this packet right here. This is what I call the statistics class, chapter 6. We're talking about variance this week. Last week we talked about centers, and one of the things that I told you is like kind of think about like a bullseye. When we're talking about the centers, we're trying to hit the bullseye. We want to know what's at the center of all the data. Like if you had thousands and thousands of numbers and digits to look at, like how can we condense it into just one number so that we know, what all of this set of data is describing or telling us what it is, what's the value. It's kind of like you just want to know the price, man. Like someone says, well, if it's this, it's that. It's like they're confusing you, and you're like, no, I just want to know what's the price. Like you want to be able to shoot right through it. Now this week it's more about like, okay, what's the range? How much does it vary? Like how wide is the target, that we're trying to hit at? Is it a small target? Is it a big target? How wide are the rings? So that's what we're going to be talking about this week, or at least in this video. It's about variance. So let's just go ahead and just jump right into it. Right here, this is part 1, and I call this domain and range. This first part is kind of like all over the place. By that I mean these are two different things. So let's just go ahead and make sure that you put your name and put the period that you're in. But we're talking about variance right now. So variance is the spread or scope of values that a function or data set can produce. Basically, again, like how wide it is. And we're gonna have two different definitions for range today, two different types. In this example, we're taking a look at all the data points, and when we talk about range in this format, we're talking about what's the maximum value minus the minimum value. And you can see how if we have the max and we have the minimum, that tells you how wide, basically the edges, how wide the data set is. So here are 5 examples. They're all different examples. They're all pretty interesting examples. If you want to try to do it on your own, this is a good time to pause the video. But over the course of a week, the temperatures recorded in a city are the following. So what's the maximum? So I think it's 25. So I just do 25 degrees Celsius minus the lowest, which is 18. Yep. So the range of this is the max minus the minimum value, which is going to give us a range of 7 degrees Celsius. Okay, so 25 minus 18 is 7, and if you don't believe me, you can just go ahead and get your calculator. Because 25 minus 18, wouldn't it be funny if I get something else other than 7? But nope, it is 7, okay? Make sure you label it correctly. Go ahead and do that for the rest. But it's super easy. It's just maximum value is 170 centimeters for heights of students. I think that's the tallest. And then the shortest would be 145, so we do minus 145. So the range in this example is 25 centimeters, okay? I always like putting a box around answers. Makes it easy to identify the answers. Next, the following set represents the scores of a basketball team in 10 games. So what's the max? Looks like it's 90. That's a good amount of points. The least amount looks like it's 68. So you want to do 90 minus 68, and so that gives us 22 points of a range. Okay? Now the next two questions, they're a little interesting. They have to do somewhat with like probability, and these are just kind of like thinking outside of the box. This is not normal. This is not what a teacher would normally ask you, but I just think it's kind of cool. So if we have a coin, and Unfortunately, I don't think I have a coin on me right now. I mean, I got a Pokemon coin, and then I got a really, really cool coin over here that was given to me by one of the counties. Actually, not a county supervisor, a congressman. Congressman Salud Carbajal gave me this. So if you were to flip a coin and you flip it 5 times, how many times, like, what's the range of the possible outcomes in terms of the number of heads? So I didn't get a head there, but this would have been a head. If I flip it 5 times, what's the most amount of heads I can get? 5. Okay. What's the least? Well, then it'd be all tails, meaning we'd get none, so it'd be 0 heads. Okay. And I guess the range of this is like, this would actually be like the real answer. Like the range is, you know, the most you can get is 5, the least that you can get is 0. I know we usually subtract it, so I mean, this would be 5 heads. But I really would rather just see it in this way. Like you see what's the least, what's the most. What's the least, what's the most, least, most, least, most. And that's what the next type of range over here is that we're going to be talking about. Let's do number 5. So probability example. A fair-sided die is rolled. Again, I don't have a die on me right now, but a die looks like, you know, the little things that people used to gamble with. And there's a bunch of little dots. And there's one side that says 6. There's one side that has 5. There's one side that has 4. Another side has 3, 2, and then 1. So the most that we can get is 6. That's the max. The least we can get is 1. So these are our values. I would still consider this as our range. But our answer would be 5 in this case. Okay? And I don't know if we would call these 5 points. I'm not big on gambling, and I don't know much about dice. So I don't know what this is. It's just 5. Okay? And a die is just one of them. A dice would be 2 of them, but since it's just one, it's just one. This is one type of range, okay, where you subtract the maximum and the minimum. But in math, there's another type of range, and that's what we're going to talk about just now. This type of range basically says, like, what are all possible values? Okay? Domain, in this case, is now all possible inputs. Okay. So these are the numbers going in, these are the numbers going out. Range is usually what most people are interested in. It's like, what can we get? You know, so it's easy to understand. Domain is the x values, all the x's when you're looking at it in a graph. When you're talking about range, these are all the y values. So you just got to remember that. Domain is x, range is y. So domain are x's, range is y's. And what I usually tell students is, imagine like you squeeze the graph. So I'm going to get imagine my fingers are squeezing this arrow pointing up, and I'm squeezing it down onto the x value. If I do that, even though there's a ton of points right here, it's going to get squished onto just this point of 2. And if I was to get this line and squeeze it from the top and bottom, and I squeeze it, okay, just another distraction. I guess today's the day that they pick up the recycling. Okay, so it would just be condensed into these 2 points. So the domain, all the possible x values, they're literally just on -3 and +2. So this is x equals -3 comma positive 2. Now, what would happen if, instead of squeezing it down onto the x-axis, what if we squeezed it like this, like flat? So usually I tell students, x domain, that's you stomping on it. The range, the y values, to find out what are the values, we squeeze it this way, okay? So we squeeze it onto the y-axis to find out to find the range. But notice how this goes on forever. So it's kind of like this goes on forever this way. This one goes down. So this is just one line that goes up and down, meaning all the values are possible. So one way of writing that is saying y equals negative infinity to positive infinity. And there's a lot of different ways to write this. Every teacher's a little different, just so you know, depending on what professor and teacher you get. They might say, oh, this is not how I want you to write it. Or they might say, it is, like myself. I think this is enough for me to understand that you understand that y can be negative infinity or it can be positive infinity, anywhere in between, okay? Now let's do another example so it can make more sense. If I squeeze this onto the x-axis, because I want to find the domain, all the possible input values, I notice that there's going to be a point here all the way up to 5, and it goes all the way over here to negative 5. But notice I put a big circle on negative 5 because that's got a big circle, and that means it does not include that value. So the domain is x is from not including negative 5 all the way to positive 5. And one way of doing that is by putting a bracket versus a parentheses. So that means bracket means includes, and then that means excludes. The parentheses just means it goes up to negative 5, but it doesn't touch negative 5, while the bracket means that you touch it, okay? Again, the domain, this is like you squeezing it down. The range, that means I gotta smack it this way. So I can see it goes all the way up to 2, and it goes all the way up to negative 2. And it does include negative 2 because this is included, that's included. Even though this one's not, over here it is. So y would be equal to negative 2 to positive 2, okay? Another way of us writing it, I'm going to show you in just a little bit. You know how I said, like, some teachers might not want this format. Some teachers might want this format. I'm going to teach you another format. And then you guys can pick whichever. I'm smart enough to understand what you're trying to tell me. So domain, in this case, notice, well, first of all, notice this graph goes on forever going up. And it looks like it's going to keep continuing, going to the right. So eventually it's going to go all the way to the right, and the same thing's going to be over here. It's going to go all the way to the left. So this graph is going to go on forever on both of these directions, okay? So that's negative infinity, positive infinity. It's basically how far we'll go left, how far we'll go right. Those are our x's, because again, this is the x-axis. So another way of writing it would be negative infinity, and then I'm going to write an x in the middle. So this means x is greater than negative infinity, but it's also less than positive infinity. Okay, so these are 3 different ways of writing your answers. I use brackets, I used inequalities, and then I just said, I just basically used an equal sign. So they all work for me. Range looks like it's also going to go on up as far as possible and then down as far as possible. So it goes all the way to positive infinity and negative infinity going this way. So range is going to be the same, but instead of an x value, remember range is the y values. So we're going to write y, and we're just going to copy everything the same. Now, we are not including the endpoints because you can never reach negative infinity and you can never reach positive infinity. So there's no little line right here in the inequality symbols saying that it includes them. Teachers don't usually include that. So that's just something for you to note. Let's flip the page. Another vocab word. I think we've already talked about it. See if you can figure it out. All possible input values, that's your domain. Okay. Output values, that's your range. Okay. All right, so take a pause. See if you can figure out the range and the domain for all of these. Okay. And then I'm going to go ahead and put up the answers in just a little bit. Okay. Domain, as you can see, it goes on forever, left and right. So that's negative infinity to positive infinity. Range, it doesn't go up and down. It actually only stays at 3. So I'm just going to write y equals 3. This example, interesting. The domain goes straight down. So I'm going to put a dot here. I'm going to put a dot there, put a dot there, put a dot there. So domain is x equals negative 3, negative 2, 1, 2, and 5. Okay, if you don't understand, you can just always ask me for help. Range, we got to flatten it out this way. So there's a dot here, this one goes here, this one also goes to the same spot, and then this one goes over there, and then this one goes over here. So remember, one of them we're squeezing down and another one we're squeezing this way. So y equals negative 5, 0, 1, and 4. Domain for the next one is going to go flat. It's going to go on forever that way. So it's going to go on forever this way. But it stops at 4. So the domain here is x is in between 4. It includes 4. So I'm going to go ahead and put a little line right there. But then it also goes on to negative infinity. So, and I don't do little include sign for the negatives. Range, it looks like it's from 0 all the way to positive infinity. So again, I'm squeezing this way. So this is from 0, include 0, to positive infinity. All right, this circle is interesting. If I want to flatten the circle, it'll go from here to here. So from negative 2 to positive 2. So it'll just be this. So negative 2 to positive 2. And if I flatten it out this way, it'll go from here to there. So 1 to 5. Oh, and excuse me, these should be brackets. Why? Because it includes the endpoints. That circle does not have any holes. Let's see, domain on this one. We did have a little conversation in class. This looks like there's a wall here, and it doesn't look like it's going to continue to the left. So at most, it's between negative 4 and positive 2. Negative 4, positive 2. And I'm going to say it does not actually reach those points. I feel like it might be getting closer and closer, but it doesn't actually reach. The range, the lowest points. So another way of asking is like, for the domain, what's the most that it goes to the left? What's the most that it goes to the right? Okay. Range is what's the lowest point? What's the highest point? So the lowest point is 0. Again, this includes 0. And then it goes on to positive infinity. And remember, we don't include the infinities. So that's a parentheses. Next problem, what's the point all the way to the left? Negative 4. What's the point all the way to the right? 3. Doesn't include 3, but it does include 4. What's the lowest point? Negative 5. What's the highest point? Positive 5. Doesn't include the endpoints because notice that these are open circles. The lowest point is an open circle. The highest point is an open circle. So that just means it's a hole. It doesn't reach it. It gets to it, but it doesn't actually reach the point. This one, what's the most point to the left? Well, it looks like it's going to go on forever. Most point to the right looks like it goes on forever. So negative infinity, positive infinity. What's the lowest point? Negative 3. What's the highest point? Looks like it goes on forever. The only one that's included is this negative 3, so I'm going to put a little line right there saying that y can be negative 3, but it can't be positive infinity. It can get to it, but it's not exactly quite it. This one's the hardest one. I'm not going to lie. Why? Because it's got several parts. Mostly it's got 2 holes. So we know the most it goes is negative 4. Then the most it goes to the right is basically forever. So this is from negative 4 to positive infinity, except it's got 2 holes, one at negative 2 and one at positive 2. You can call those gaps or holes. The range, the lowest point is negative 4. Again, doesn't actually reach it. And the highest point is 1, doesn't actually reach it. And this one over here, domain, the most it goes to the left is negative 3. The most it goes to the right is positive 3. These are included. The lowest point is negative 2. The highest point is positive 4, and these are included. So hopefully these make sense. If they don't, make sure you guys ask me for help. But these are 2 different types of ranges, okay? In this example, it's ranges all the possible outputs. In the first example over here, we're talking about range is just the maximum minus the minimum. Either way, it's telling you basically how far it goes left and right. You know, like it's very similar. And then domain is almost like it's 2 different types of ranges. It's just like what's the left and right, and what's the down and up. You know, so let me know if you guys have any questions. We're now gonna move on to box and whisker plots. A lot of people just call these box plots. But I like calling them box and whisker plots because they remind me of a cat. And you guys know how I have a cat now. So actually, I don't think that looks like a cat. It kind of looks like a piggy. But a box plot kind of looks like that. It's literally a box with a line in the middle and then 2 lines going off to the side. And then there's several dots, okay? So it's not really a cat, but this is what a box plot looks like. And we're going to work on creating box plots today, right now in this class. So let's go ahead and just get started. So, and then you guys can read the rest, but this is the definition of a box plot. We will first create a box plot by arranging the data set in ascending order, meaning from lowest to highest. So we got to arrange this data set from lowest to highest. I think 45 is the smallest number. Then we have 65. Then we got 70, 72. 78. 80. 82. 85. 88, and now I think we're gonna get in the 90s. So 90, 92, trying to do 2 at once, and then we got a 95 and a 100. Okay, so that's the first thing we do. Arrange the data set in order. You got to make sure you do that first. Then we're gonna calculate the interquartile and the outer quartile and then the middle quartile. So what does this even mean? Remember how I drew like a box with the line in the middle and then some whiskers on the side? Well, Q1 is this line. Q2 is this one right here. And Q3 is this one right here. This one's technically Q0 and then this one's technically Q4, but no one ever calls those. They just call them the minimum and the maximum. Okay, so we don't really call that, but if you want to be cool, you can say Q0, Q4. And essentially, each of these is 25% of the data. So this is 25, this is 25%, this is 25%, and this is 25%. This is why they call them Qs for quarters. So quarter 1, quarter 2, quarter 3, quarter 4. And this area is important because that's where 50% of the data is, 25 plus 25, and that's where all the center is. Think of this as like a, you know, like the target that I was talking about. And then this is like the outer part of the target. So it kind of gives you an idea, like just a little bit of how far the area, the data values are spread out. So anyways, how do we calculate the interquartile range? Interquartile range is this, between Q1 and Q2. So you first want to calculate what's the middle number. So usually what I do is I don't cross these out. I just count, like, I think there's probably like 5 numbers. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we still got a couple. We got 3. So I'm just going to cross out 1 on the left, 1 on the right. So this right here is my Q2. Then what I do is we want to make sure we get an odd number. Okay, on the right. Okay, odd. And 1 on the left. So I need to count how many numbers we have over here. So I'm going to count the middle one. 1, 2, 3, 4, 5, 6, 7. Okay, good. And so now I know there's 7. So there's 7 including 82. So now I'm going to go ahead and cross them out. I'm going to cross out 1, 2, 3. And then on the other side, I'm going to cross out 1, 2, 3. And so this right here is my Q3. And you always want to get an odd. If we would have gotten an even, then you don't include the middle number. Okay, and I'll show you that in just a second. So I'm going to do the same thing on the right. I'm going to cross out 1, 2, 3, 1, 2, 3, and 72 is Q1. Okay, so now I got my Q1, I got my Q2, I got my Q3, and technically I know my endpoints as well. So now I can go ahead and draw a number line and mark the quartiles and the median. So I'm going to draw a number line. Smallest number is 40. Goes all the way up to 100. And this is going to be 40, 50, 60, 70, 80, 90, 100. Okay, and speaking of cats, we've got Lucy right here paying us a visit. I don't know if you guys, oh, she just ran off. Okay. I don't know if you can hear the little bell. But anyways, we're going to go ahead and mark the quartiles. I'm going to go 45, 72, somewhere over here, 82. You can see her hairs. I almost got her. 82, 90, and 100. Okay, so we got all 5 points. And the 3 points in the middle, the interquartile, we're going to put a box around those 3 points. And then we put 1 in the middle. And then we draw the whiskers. Okay? So as you can tell, this is a long whisker. That means that these numbers are spread out and these are more bunched in. So usually it says like, hey, this is where most of the data is located, and that's what we're interested in. It's between 70 and 90. It's really 72. Remember, this is 72 and 90. So between 72 and 90, and with 82 being the median. So we already did that. Draw a box spanning, and then we already drew the whiskers. This is what you're supposed to do. Okay? Here's our box and whisker plot. We're going to do a couple more of these, okay? We're going to get some practice. So, let's see, where are we going to start? We got to put the numbers in order. Thankfully, Mr. Martinez put these in order for us already, so we're just going to go ahead and count. Let's do 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and that's good. We got 2 numbers in the middle. So you should know what to do when you have 2 numbers in the middle. You add them up, you take the average. You can get a calculator if you want, but we know that this is going to be 36, okay? So 35 plus 38, we add them up, and then we divide by 2, and we get 36.5. So that's our middle number. or our Q2, okay? Now we need our Q1 and we need our Q3. So remember, you got to count. How many numbers are there? 1, 2, 3, 4, 5, 6. Ooh, so that's not good. I need an odd number. So I'm just going to count the lines. 1, 2, 3, 4, 5. So, okay, we're not going to include these, okay? We're just going to include these. So I'm going to do 1, 2, 1, 2. And so this is going to be my Q1. And then I'm going to do 1, 2, 1, 2, and this is going to be my Q3, okay? Now, if you wanted to, you could take the average of these two, and so you could say it's really 29, and you could take the average of these two, and you can say that this is 43 and a half. It just depends teacher to teacher. I've learned it several ways. This is probably not the most straightforward explanation, but let's draw our number line. Smallest value was 20. Biggest number was 60. So we're going to go 20, 30, 40, 50, 60. 20, 30, 40, 50, 60. I'm going to I'm going to put points for my Q1, Q2, Q3. So 28, 36 and a half, and 45. I put a box around these, my interquartile range, and then I'm going to draw my whiskers to the minimum and maximum, okay? Now notice this one is skewed to the left, okay? And those are height of plants. So that means that most plants aren't growing as fast, but there's a couple that are growing kind of fast. Now, levels of income. Now, these I do have to put in order. So I do have 30, then I got 32, then it's 33, then it's 35, then it's 40, then it's 45, and I see that it's 50, 55, 75, and 80. All right, so let's see if there's an even number, an odd number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since there's 10 numbers here, it means that there's going to be 2 numbers in the middle. So I'm going to cross out 4. 1, 2, 3, 4. 1, 2, 3, 4. These 2 numbers, I'm going to take the average of 40 and 50. That gives me 42.5. Okay. On the left, I count 1, 2, 3, 4. That's even. I need an odd, so I'm going to include 40. So I'm going to cross out 2. 1, 2, 1, 2, and so then 33 is in the middle. I'm going to cross out 45, 50, 80, and 75, and I get 55. Okay, so those are my interquartile range numbers. I'm going to draw my number line. It's going to go as low as 30. As high as 80. So there's going to be 30, 40, 50, 60, 70. And I got to now place my interquartile numbers. So 33. It's actually over here, because this is like the halfways. 42 and a half. 55. I draw a box around these. Then I draw my whiskers. Now notice that this is like really like staggered on the left side. What does this tell you in terms of income levels? It means that most people don't make a lot of money. This is 75% of the people. And then this is 25% of the people. So that means that this is more spread out, and it makes sense if you think about it. There's a lot of people that earn about the same, like, close to minimum wage, and then there's a couple people that earn like way more than minimum wage. But I want you guys to be on this side, if anything, past the 80, because this isn't thousands of dollars, so this is like $80,000 a year. We're gonna draw one now for 2 classes or 2 data sets, and they just happen to be scores per class. And so what I want you guys to do is make sure that they're in order first, and they're almost in order: 72, 75, 78, 80, 82, 85, 88. And then I noticed that I kind of messed up, so I did 90, 93, excuse me, 92, 93 should be here, so I'm gonna cross that one out. Then I'm gonna do 95, 95, and 100, okay? So I try to make it easy for you guys. The one on the bottom, I noticed that there's a 65 over here, so this is gonna be 60, 65, and then 65 again. Then 68, then 70, and then I noticed that there's two 70s, then 72, then it goes 75 twice. There's another one over there. Should probably cross those out. And it's 78, 82, 85, and 88. Okay. So some of these might not have even or odd, or they might be odd. Well, we want odd. We want odd numbers, okay? So some of these might be even. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, that's odd. So that means that we're going to have a number in the middle. So I'm going to cross out 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 88 is my middle number, my Q2. And now I want to count how many numbers on the left. 1, 2, 3, 4, 5, 6. And I'm going to include this one, 7. So that way it's odd. And so now I'm going to cross this one out. 1, 2, 3. 1, 2, 3. And so 80 is my Q1. I'm going to do the same thing over here. 1, 2, 3. 1, 2, 3. So 93 is my Q3. Okay? Now the data set B, the one on the bottom, I think it's even if I remember correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, wait, I guess it's the same amount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's just check I didn't miss one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so this, I must have made a mistake earlier. But we're going to cross out 6 numbers. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have 72 as our Q2. And then I'm going to cross out 3 on each side. 1, 2, 3. 1, 2, 3. Q1. 1, 2, 3. 1, 2, 3. Q3. Okay. Now, what are we going to do in this example? We're going to compare 2 data sets by creating a separate box and whisker plots for each class, but on the same number line. So the lowest number, I think, is 60. Highest number is 100. So I'm going to go 60, 70, 80, 90, and I think we're going to have to cross this out and do 100 right there. Okay, so let's do the class A, period 1, which I'm pretty sure you're from period 1 because you sound like you're super smart. And it looks like this is our smart class. So Q1 is 80. Put this on the top. Q2 is 88. Q3's, oh, I think I already messed up. So 80, 88. Oh, good thing I saved myself. So, and then 93. That looks like that's 93. So I'm going to put a box around these. Then I'm going to draw my whiskers. So it goes all the way to 100. And this one only goes up to 72. That's the lowest score for this class. So this is class period 1. Okay, those are the scores for period 1. Over here on the bottom, data set B, the lowest value is 60, but let's do the Q's. So 68, 72, 78. Put a box around these. And then the whiskers, that highest was 88. The lowest was 60. Now you can tell for sure that this is big differences, huge differences. This class did way better. How much? This is 75% of the class. 75% of this class did better than 75% of this class. That's a big difference because this is 25, 25, 25. Only 25% of these students did better than the worst class, worst 25% of that class. So box and whisker plots allow you to compare the data, and that's what's super cool. Okay, let's go on to the next part. Just in case you were wondering, this is early in the morning before I have to go teach, and I'm running out of time. I'm gonna have to leave soon, so let's see how much I can get done. Okay, I think I can get it done fairly quickly. Usually I end my videos kind of fast. So deviation is the word for this part 3 in this chapter 6. Deviation is and more specifically standard deviation, it's a fancy formula. I'm gonna make it super quick, okay? It's a fancy formula. Now this formula is complicated. If you wanna see what it looks like, here's a formula, all right? This stands for standard deviation. This means that first you gotta find the average. You subtract every single value from the average, you square it, and then you add up all those values, and then you divide by n, okay? Not easy to do, okay? I basically had my college students find the standard deviation for over 100 values, and let's just say they all messed up, okay? There was nobody that got it right. And I do that to prove to them that, hey, even though you know how to do it, you probably shouldn't do it. Instead, you should have the computer do it, because the computer does it like this, and it does a really, really good job of doing it fast, and you save time, and you also get the answer correct. So, but I still want you to understand what standard deviation is, and I want you guys to appreciate how difficult it is to calculate standard deviation. So let's take a look at this. So we got all these numbers. The first thing you got to do is you got to find the average. So that means that you got to get your calculator, and you're going to do 5 plus 9 plus 12 plus 12 plus 13 plus 14 plus 15 plus 17 plus 20. So you get the total. It's 117. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So you divide by 9. I must have done this on purpose because we got a nice number. So the average, this is X bar. X bar means average. Okay, anytime you see an X with a little line on top, that means the average. Then you got to subtract the average from each of these. So 5 minus 13, 9, and we're going to add them all. 9 minus 13, 12 minus 13, 12 minus 13 again. And it doesn't matter which one you put first, because you're going to square it. And when you square it, it turns negatives into positives. 13 is going to be, obviously this one's going to be 0. And then we're going to get 13 minus 14. I'm going to make some more room over here. So 15 minus 13. And then we are going to do 17 minus 13. And then 20 minus 13. Okay. So you then figure out what this is. 5 minus 13 is 8. And you're going to square that. 9 minus 13 is 4. You're going to square that. And you're going to add all these numbers. So that's 1 squared, 1 squared, 0 squared, 1 squared, 2 squared, 4 squared, 7 squared. Now that's 64. 16, 1, 1, 1, 4, 16, 49. You're going to add up all those numbers. Okay. And then you're going to take the square root after you divide by however many numbers we have. And we got 1, 2, well, we have 9. So this is a crazy long formula. I'm just showing, you're not going to do this, okay? You're not going to do this. You're just only doing it once right now. So we do 64 plus 16 plus 1, 2, 3 plus 4 plus 16 plus 49, and I hope I did this right. It's 152 divided by 9, and then that gives us 16.8. We're going to take the square root of that. So second square root, 16.8, and that's going to give us about 4. Okay, so what does that mean? What is this fancy number that we had to do all this math that you don't even know what we're doing or what it means? Okay, super complicated. Basically, we know the average is 13. Okay, we calculated the average. So I'm going to put 13 here. Okay, and the 4 means that you add 4 to 13. 1, 2, 3, 4. So that gives us 17. And you subtract 4. 1, 2, 3, 4. So that's 9. That means that in this area, we're going to do like a little fancy hill. Here's the average, X bar. This right here represents most of the data. How much? About 68%. Okay? Now, I'm not going to make you guys do the formula and do all that. I'm just going to say, hey, this is standard deviation. In this case, 4 was our standard deviation. And so then, since I have 4, you then need the average, and then you add the standard deviation, and then you subtract that standard deviation, and it gives you the range, okay? Or the variance, that's what we call it. So let's do some examples. So, okay, just so you know, this 4 right here, that's that right there, that's standard deviation. And then this is your average. So those are the 2 things that you need, okay? All right, and I believe measures how spread out the numbers are in a data set. I think this is, again, variance or standard deviation. I'm gonna have to double check. I'm running out of time, so I'm a little nervous. So if I tell you that the mean is 160, you put 160 in the middle. If I say the standard deviation is 10, you got to add 10, so that's 170, and then you subtract 10. So from 160, that's 150. So go ahead and shade this in. Most of the data, 68% of the data, is between 150 and 170 of the height of students. Now, what about test scores? The average or the mean is 75. Standard deviation is 5, so I'm going to add 5, so 80. Subtract 5, 70. So most students, 68% of students, got scores between 70 and 80. Now what's interesting is a standard deviation, you can take it up another notch. You can add 5 again, subtract 5 again. And so now all this area now represents 95% of all the students. Notice how these got smaller. But I really only test you guys on the 68%. But if you wanted to know, you can go up to 3 standard deviations. 1, 2, 3. 1, 2, 3. I just ask you where's most of the data, so we just do 1 standard deviation. So we'll say for monthly expenses, $1,000. Standard deviation is 200, so that's $1,200. Subtract $200. So that means most people spend anywhere between $800 to $1,200. Temperature in Celsius, because we want to go to Europe. The standard, the mean right now is 20 degrees Celsius. Standard deviation means you add 3, so that's 23 degrees Celsius. You subtract 3, that gives us 17. That means most of the temperature is between 17 and 23. See if you can do the last one, but so you can pause the video, but the mean is 0.5 seconds, whatever this is, reaction time. Standard deviation is 0.1, so I'm going to add 0.1, I'm going to subtract 0.1. That's most people's reaction times. And obviously you can keep going lower to calculate everything, but I'm only looking for the middle part, okay? Now you're also going to do this for your data. And if you want to do this for your data, you have to pull out your your survey. So we're gonna go into the survey right now because the last part is asking you to write in your questions and then also tell me the standard deviation. So let's go over here to the sheet. So in the sheet, we already calculated a mean, median, mode. We want to now calculate standard deviation. So I'm going to type in standard deviation. Make this bold. And then right next to it, I'm going to type in equals ST. And then you see that standard deviation pops up. Click on it and then select by clicking and holding the mouse all the way to the top. So you're going to drag it and then hit enter. There's my standard deviation. And if I want to get the standard deviation for all of these, I'm just going to spread them out. And now I'm going to use my mean. I need the mean. So let's go ahead and highlight this yellow. And then I'm going to highlight my standard deviation in green. Hope that's green. And then these are the numbers I'm going to use. I have my questions here. How confident from 1 to 10 are you? What's your percentage? If you earn this much, if you have that much money saved up. And so I got my means and my standard deviations. So let's go now to the worksheet. So if I actually, it might be easiest if I actually show two of these. Let's see, this one, I don't want that. So let's see, I'm gonna try to show the visualizer. Okay. All right, so I think I got it. So what we're gonna do is we're going to write our question here. And my first question is, from 1 to 10, how confident are you? So from 1 to 10, how confident are you? And I'm not gonna write it all out because, like I said, I'm running out of time. That you're gonna retire as a millionaire. So the average in this case, if you see, it's 6. So I'm gonna write 6. Standard deviation is 3. What's the 68%? So I'm gonna add 3 to that and I'm gonna subtract 3. So what's 6 minus 3? 3. What's 6 plus 3? 9. So most people are between they're all over the place, okay? Let's take a look at the next one. What percent would you save? Okay, here's a question. How much percent of your income would you save? How much percent of your income you'll be saving for retirement? The average is 15%. So most people said they'll percent to save. Standard deviation, this is interesting. It happens to be 15. So if I subtract 15 from 15, it's 0. If I add 15 to 15, that's 30. So most people are going to save between 0 to 30%. That's what that means. And obviously you can't go below 0, so this is a wall. Okay? This does not exist. That doesn't exist. It goes as far as 0. Okay? Now that's what you guys are going to do. You're going to look at all of these. You're going to write your question, put your average. You're going to put the average right here. You're going to write your standard deviation. There's my number. You put your standard deviation. And then you're going to subtract and add this number from the average. And then you're going to add it over here. Okay? So you got to do this for 5 questions. If you guys need help, you know I'm always here to help you guys. It's a very interesting chapter. I know we're learning about standard deviation. A lot of people don't think that high school students can learn about standard deviation, let alone students at Frontier. I, however, believe in you and I believe that you're smart enough. I just need you to be careful with your thoughts and say that you can learn this, because we're only really looking at 2 numbers. What's the number in the middle? What's the standard deviation? And that tells us how wide it is. This is a very fancy number, which is why it's something that most people don't learn until they get to college. I don't think it's something difficult to learn. Maybe it's difficult to do the whole equation, and do all the calculations, as you saw that there's a lot of steps. But the truth is, the concept is not that difficult. We got the average. Standard deviation tells us how much we can move left and right, okay? And so you just gotta add and subtract, okay? Make sure you guys give this video a like and a thumbs up, because I'm going above and beyond for you guys. I love you very much, as you all know, or else I wouldn't be a teacher, I wouldn't be teaching. And if you guys have any more questions, make sure you guys ask me, either in comments or send me an email or in person. I'm here to help you guys, all right? Have a nice day. I'll see you guys in class right now. Bye.